Hello everyone and welcome to this online lecture session. And in this online lecture session, we are going to study about operators in C. As you know that these are major categories of operators in C, which includes arithmetic, unary, relational, logical, assignment, and conditional. And we'll see that in this section, we'll discuss about each operator and see some examples of all of these categories. So first one is arithmetic operators. As we are already acquainted with the arithmetic operators in mathematics, so C also supports some arithmetic operators. So you can see these are the 5 important operators shown in the table, which includes our addition, subtraction, multiplication, division, and modulus. Right? And just you have to remember that we don't in C we don't have the privilege of exponential operators. So for whenever we need exponential operator, we're going to use the power function, which is provided as a predefined library function in the header file math.h. And remember, for all these operations, the operands could be should be a numeric value, can be an integer quantity, can be floating point, and can be a character. Especially whenever the operand can be an integer, in those places we can replace with the characters. But remember, for modulus operator, or we say the percentile operators, a remainder operator, both the operands has to be integer type, because it works on integer type. Otherwise, when you compile your program, you're going to get the compilation error. So how the use are as usual similar to the mathematics. As you can see that for plus we can use like variable 1 plus variable 1 plus variable 2, num1 plus num2, net amount minus discount for using subtraction, multiplication, because here you don't use cross, we use the star, the asterisk. We also call the asterisk operator, asterisk symbol for multiplication operator, and slash you say the slash, the forward slash used for division operation, and the percentage is a modulus operator. Now remember, it's a very common thing that we will never use the denominator as 0. Okay, that is a mathematical rule that when you divide two variables a and b, or two values a and b, the denominator b shouldn't be 0. Now in C, we'll find whenever you perform a division, it could be either an integer division or floating point division, depending upon what kind of data types are these operands belongs to. All right. Now, when you say that a division is going to be a whole division, when both the operands must be integer, right? So, like suppose I choose the denominator and the numerator both maybe an expression or maybe a variable, which will lead to an integer type. In that case, the division going to be whole division. That means in the result, even if we will have a decimal part, the decimal part will be truncated. Okay, only the whole part will be the result of the division. That's why that is called the integer division. Whereas in floating point division, you will have the decimal part. Will have the values depend upon how many what point of decimal it is calculated. It will be there as a part of result of the floating point division. So to perform a floating point division, you have to make sure that one of the operand, either the numerator or denominator, is a floating point type. Means can be a double, can be a float, or can be a long double, something like that. So that in that case, the division will be a floating point division. Means we'll end up with the decimal points. The decimal parts will not be truncated, just like integer division. We'll see an example of this in the later part of this slide. Now, if there are more than, we can see that if there are more than one operators present in an arithmetic expression, suppose we write an arithmetic expression and there are more, in that case, we know that the precedence is applied. Okay, whichever operator has the highest precedence, that will be evaluated before other operators. So in C also we follow the same rule, but here the precedence is defined as with the group of operators. So in arithmetic operation, we have two group of precedence. The first group, which is highest precedence, are the multiplication, division, and the modulus, and they have higher precedence over the remaining operators, that is plus and minus. Plus and minus has the same precedence. That means whenever you find a plus or minus, we cannot say just like math, we used to evaluate the plus first, then the minus. So here plus and minus are both have the same precedence. For example, let's say we have a let's say we have an expression like this in my in my program. Let's say I have a C, let's say for example, let's say D equal to, I'll say A minus B plus C. Okay, if you have an expression like this, so here, as we know, according to mathematics, first B plus C will be evaluated, and then that value is going to be separated from A. But according to C, because minus and plus both are going to share the same precedence, whenever we find a situation where both we have multiple operators in an expression having the same precedence, in that case we apply the rule of associativity. Okay, as you can see in the slide. Okay, the order in which consecutive operation with the same precedence group are carried out is known as associativity. We apply associativity rule to evaluate the operators which are of same precedence, which belongs to the same group of precedence. So for all arithmetic operations, most of the all arithmetic operators are, especially these 5 operators, which are all binary type, the associativity is left to right. So that means here this expression, as you can see that here, since minus and plus both are having the same precedence, the evaluation will be done from left to right. So from the left point onwards, you will check for the operator which appears first. So since minus appears first B will be subtracted from A, then the result will be added to C, which will be the final result that is to be stored in the variable D. Right? So here it doesn't matter in the output, but there will be some expression when you change the order of evaluation, okay, which is not as mathematical Bodmer's rule. So you will get definitely different value compared to the way you evaluate in mathematics. So you have to be very careful about this, about applying the precedence as well as the associativity rule. Some more rules that when we have operands with negative value, then the normal rule of algebra is applied. That means if I have an expression like this, for example, let's say A equal to 15 plus say I say minus 34 or minus 35. Okay, that means here we can write it to just I don't know, clearly show that it's a negative value. So if this kind of situation is there, definitely the normal algebra rule is applied. That means the 15 will be the 35 will be subtracted from 15, or it will result in a negative value, that is minus 20. All right. So such kind of rules are which is there in mathematics will be applied same as it is appear in the mathematics. Now, the natural precedence operator can be altered through the use of parenthesis. So as in the mathematics, the parenthesis has the highest, the bracket has the highest precedence. We can also use the parenthesis here, not only not only sequentially, but also can be in a nested way, depending upon which portion or which sub expression you want to evaluate first. So for example, suppose I let's go to the next example for this so that we can understand it more better. So look at this example. So if you normally when I write, let us say we'll remove this line, this parenthesis. For example, assume that there is no parenthesis here. All right. So in that case, what happens? So we have the star has the highest precedence. So because there are 3 star or 3 multiplication operators are present here, that will be evaluated from left to right, associativity rule. So first A will be multiplied with X, whatever the result value will be multiplied with X, this X, all right. Then B star X, right? So here's the thing. So putting parenthesis here, actually doesn't change the rule here, mostly doesn't change the rule. But think of the situation, if I will just remove this parenthesis, if I will remove this parenthesis here, if you just look at the in that case, definitely parenthesis is going to alter the normal steps of evaluation, normal step evaluation of this, or evaluation of this expression. All right, that means here, because b star x is present within the parenthesis, first the b star x or the b into x is going to be evaluated before the a into x into x. So that's what parentheses can play the role. So whenever you need to have to put in higher precedence to a particular sub expression or anything, you have to enclose that within the parentheses. So this is again same as the mathematical rule. Just to make sure that it works. So let's go back to our original expression. So in this case, let us see how actually in C it is getting evaluated, just following the rules of C. So let's say A is equal to 2 and B equal to 3 and C is equal to 7 and X equal to 5. So let's say in this case, what is going when you say for A, X, all values will be substituted here at the first point, as you can see here. All right. Next comes to evaluating it. First, parenthesis, definitely. So there are more than one parenthesis. Again, it will go from left to right. So first parenthesis right here. All right. In this parenthesis, we have two multiplications. Again, there are two multiplications share the same precedence. We'll evaluate from left to right. Okay, so it is not actually not going away from the normal the traditional normal process without parentheses also. All right, so first 2 into 5 will be evaluated. It becomes 10. 10 will be multiplied with 5. Then it becomes 50. Then to the next part, b star x. All right, so b star x gives 15. All right, 15 will be added with 50 because there are two pluses here, again left to right. So actually this expression doesn't much alter the process when you apply parentheses or have multiple operators with the same precedence. But you will find some expression when some exercises, you will see that there will be some expression when you evaluate mathematically, they will have different output, whereas we'll evaluate according to the C rule, C arithmetic expression evaluation rule, will find different output. All right, so we'll conclude that this value will, finally the value will be 72, and 72 is going to be assigned, okay, using the assignment operator to the left hand side variable y. All right, this is how a normal arithmetic expression is evaluated. Let's see some programs here. So let's analyze this program, how this program works. Very simple. We have an integer, we have declared and initialized two integers a and b with 10 and 3, and another integer ri to store the result of the integer operation. Then we have float m, which is 12.5, and then n, which is 2.0, and another variable of float, that is rf. Similarly, we have a character c equal to p, p and d equal to t and rc. So first operation is the modulus operation. A mod b means the remainder when a is divided by b, which is going to be 1 here. So ri is going to hold 1. Similarly, when m is divided by n, 12 is divided by 2, 12.5 is divided by 2. So we'll get 6.25. So the resulting rf is going to store 6.25. All right. And c plus d, c p d representing characters, so the corresponding ASCII value will be added up. Now since p and t values, you can imagine these two p and t values are we will add this up, it will go beyond to 127. So we are expecting that when you print it is an integer value, we'll get some negative value. Now look at the right hand side, the example we have just discussed. The output is going to be 72 for the left hand side. Now these are some exercises for you people to write a program to write the area of the rectangle and the area of a circle. Okay. Then important thing when we are evaluating an arithmetic expression is a type conversion, because we are associated with different type. It may happen that we will end up with the expression containing more than one different type of data types. The variable that are involved in the expression may have different type. In that case, type conversion happens from one type to another type, because the evaluation of expression will be done when all the variables which are present in the expression are of same type. Operators, what I've seen so far, arithmetic expressions, they operate on the operands of same type. So suppose I will take an a and a, let's say I'll take an example like this one. Let's say let's say a equal to, for example, b plus c, and let's say b is of integer type and c is of float type. So in this case, operator actually, for us mathematically we know that we can do it easily, but when we execute this one, first of all, b will be converted into floating point type. Okay, not that C will be converted to integer type. B will be converted to floating point type. Mostly the both will become into double type. Then they are going to evaluate. So plus will ensure that the operator plus or any arithmetic operator ensure that both the side are of same type. If they are not of same type, the type conversion is actually performed. All right. So there are two way the type conversion can be done. One is implicit one and explicit one. So during evaluation, when automatically conversion is happened without intervening or without involving the user to explicitly prompt that, okay, what type of type is required. So it is implicit conversion. Generally, in implicit conversion, a lower level data type, when we say lower means their size is smaller, okay, is converted into a higher data type. Implicit conversion will find out which among the operator has the smaller size, will be actually promoted, will promote to the higher size and then evaluate the expression. In explicit, we have to particular specify. In that case, the compiler cannot figure out to which data type the particular operand need to be converted. So it has a confusion that whether which type of red type I should convert it so that I can complete the evaluation. So in explicit conversion is required when the compiler cannot figure out how to perform the operation. In that case, it will ask for the user to explicitly mention the type to which the operand need to be converted. All right. So in that case, it's called typecasting, and we'll see that the typecasting will be generally done by putting the data type inside the parenthesis. You don't have any example for this moment now, but no, you'll see that example. You'll see when you use the keyword like void. At that time, we'll show an explicit conversion by using typecasting. Let's see an example here, the conversions. Okay, only I can show you that here most of them are implicit conversion. The compiler will take care of this conversion automatically. But to make sure that when compiler is automatically converting it, it is converting exactly the way we want the output is. Okay, so let's see the first example here on the left hand side. A is 10 and the other variable b is declared. Then floating point c is equal to 34.567 d. Then we write d is equal to a. Okay, so if we write d is equal to a, now whatever the value of a, 10, now is expressed as a floating point value. So d will be 10.0. Okay, we can say, because now same value, but it is the 10 is represented as a floating point value. Now when you print here, as we know that when you print a floating point value, the decimal, it will show up to 5 decimal points. Okay, so 6 decimal points. So it will print as 10.000 up to 60. So right. Next, b equal to c. What is c? C is a floating point type. When we assign c to a b, we are doing from higher to lower. In older compilers, for these cases, the compiler will prompt the user during the compilation time, say that a conversion is required. Okay, the type mismatch. So there we used to provide the typecasting here. So in the bracket, we'll mention that it's integer type. And integer type, we'll do that. All right. So to make sure that it is converted into integer type. So compiler will be sure that, because compiler know that when I'm going to forcefully do it, there will be loss of the data here, because we're losing the decimal part here. So, but in the recent compilers, they will automatically come. C will be now converted into integer type by truncating all the decimal part. All right. So when print here b, what are we going to get? We're going to get 34. Now character d. So d is like 97, 99, 100. D is 100. All right. So d is D, when we assign D equal to CH, all right. So look at the D here. D is of floating point type. When you do D equal to CH, the ASCII value of CH is now 100. So 100 will be treated here as a floating point type. So when you print it, D will be printed as the value of character, ASCII value of character will be printed as a floating point type value. Okay. So let's see this example here. So I have these examples I probably already written. So let us open this and see this. Okay, so this here is the example. I think you can see from the screen. I'll just raise the font if possibly. Okay, just I'll raise the font so that I will raise up to just one more. That will be okay. Okay, I think this font is good. So this is the program. Let us compile and run this program. So I'm going to use terminal to compile this. See, so this the file name is type conversion.c. Let's see the output here. Right, so you can see that D, when first value A is assigned to D, let me make it larger so that you can see the output again. Proceed. Now we'll increase the font just a minute. Okay, so here is the output. So you can see D is 10, B is 34, and D again, when it's assigned to a character of the value D, okay, small d, we get the ASCII value of small d represented in terms of floating point number. All right. Let's go to the second example, which is where we can find a scope of explicit conversion. In the second example, you can see we are asking user to input two values, A and B, and dividing the value of B and storing in the result. Now you can see that the data type of A and B are integers, whereas the result is stored in a floating point type. Right? So means A and B both are integer. When we divide them, this is going to be an integer division. That means it won't result in any decimal part. So doesn't matter what fraction it actually generates, the resulting value that is stored in RES will have no fractional value. Means it will have fractional values as zeros always, because this division truncate all the part. Because when we before assign to result, this value first becomes an integer division, then that integer is converted, the result of this division is converted into floating point type, then that floating point type is assigned to result. So that's why during the division itself, that the fractional part is lost. All right, so it will always end up with the. So when you're doing this kind of expression, you may lose the you may not get the desired output if you're expecting a decimal value, means the exact division value. Let's see, let me run this program and show you, so then you can figure out. So okay, right, so let's say I'm giving, let's say 5 and let's say 3. 5 is 3, that's fine. Okay, just a minute. Okay, so let's compile again. Actually, I have already modified that one to to the conversion types. Let me go to the original file. Let me open this one. PIS type. Okay. So this is the program we're looking for, right? Let me compile again and do it. So I have, because I get that upgrade. So I'll run now. Okay. Let's say I'm giving 5 and 3, as I said. So output is 1.000 because the fact when I divide it, the fractional part is lost. Okay, but I'm going to get that the 4 as when I divide by 3. Okay, then we get 6. Oh no, 6 repeatedly. So you're not getting it because this division, after the division, all part is truncated before assigned to the result value. All right. So what we should do here? So if you see this kind of situation where we require the fractional part, but we cannot change the data type of the variables a and b, then we can take the help of the floating point division by forcing it to be a floating point division. So what I can do, I will do now explicit type conversion here. All right, in this example, or no, I'll look at this. Here is the example. Okay, so what I'm going to do is I will convert one of them, because before performing division, I want to make this division as floating point division. So before making this division, I want to make one of the data type forcibly into a floating point type. So let me float here. That's it. Okay. So this is called explicit time conversion. All right. So be writing like this, a data type within the parenthesis before a variable or before an expression. Okay. Convert that expression or variable into this type, desired type, forcibly. Okay. Forcibly. So now, suppose there is a floating point value and I do integer, I'm definitely assuming that there will be some loss. But here, B will be now a floating point type. So that makes this division a floating point division, and I will get the desired result here. So let us compile again this one, and we'll execute and see that, and we'll get again 5 and 3, and we'll get the fractional part. Okay, so this is the thing what happens generally in type conversion. So you have to make sure whenever a explicit conversion is required, you have to make exactly in that place so that you will get your desired output. So this is all about arithmetic expression. We can explore more about all these operators by doing more exercises. Next comes to the next category is a unary operator, which is unique in C++. Unary operators, we know the basic unary operation in mathematics are unary plus and unary minus to indicate the sign of a particular value of a constant. All right. So like you see that sometimes we explicitly mention plus 15.7 or plus something. And whenever there is a negative number, we are bound to mention the negative sign, that is minus 56 or minus 101, like that. All right. So these two are already present inherently kind of from the mathematics. Additionally, we have two operators called double plus or plus plus or minus minus. We call them in the increment and decrement operators. All right. I don't think I have to explain about how to use minus here. Everybody know about how to use minus, unary minus or unary plus in mathematics. Wherever required, we can use them. So let me describe more about here the increment operators. Okay. So increment operator and decrement operator, they can be used two way. Okay. So this increment operator can be used is a unary, can be used with the operand either with prefix and the postfix format. So inc increment is a variable inc, plus plus means okay, it is okay, you can see that it's a post increment. We see this one again. When there is an increment on the left hand side is pre-increment. All right. So minus minus decrement value, decrement minus minus. So this operator can be used in this format two way. Okay. So minus minus or plus plus or minus are the pre-increment decrement operators. So whenever this plus plus or minus minus appear on the left hand side of the operator, you can call it a pre-increment operator, pre-increment or pre-decrement operator. So that means, what is the meaning of this? When you write like this, it is not equivalent to the plus plus I. Both are different in the term of the way they are evaluated. Right. So plus plus I means first I is increment. They actually indicate the increment operation. All right. As I forgot to tell you that increment means plus plus I means increment the value of the variable by 1. Similarly, when you have minus means decrement the value of the operand or the variable by 1. All right. So the plus on the left hand side, right hand side, they say that how increment should be done or how decrement should be done. When plus appear on the left hand side, then the increment should be done before the value is applied as a part of expression. So when you doing it independently, in a, like I write b equal to plus I. So that means here before it's saying that first increment the value of I, then assign the value of I to the b. All right. When it comes to post increment, first use the value of I for the expression wherever it is there, then increment the value or decrement the value of variable. All right. So that's why it's called, the name is called pre-increment, post increment. Will be more clear. Let's see with an example. Okay. So the previous incrementer is written as plus variable. Okay. The statement, suppose we write that res equal to plus variable. This is equivalent to writing first var equal to var plus 1. Increment the variable first by 1. Then assign this variable to the result variable. Whereas in post fixed increment, the plus is appearing on the right hand side, and when you write a statement like res equal to var plus, it is equivalent to first assigning the value to the result, okay, then increment the variable var with 1. All right. So the unary pre-post increment operators behave, all right, pre and post increment operators, they will behave in the same way. All right. So so the way we are writing here, you just replace plus by minus symbol. Okay. So the things work exactly the same way. That's the meaning. Here is the example. Let's understand how it works. So we have declared 4 variable in advance just to before we are going to use. So we initialize a and b by 10. Now see this expression, c equal to a plus. So that means it is a post increment. That means first a is assigned to c. C will hold the value now, which is equal to a is equal to 10. All right. Then the value of a is incremented. Then a is updated. A becomes a plus 1. That is 10 plus 1, 11. So when you print the values here, C and D, we're going to see that first C will be here, will be 10 because C is assigned A before the increment. This is a post increment. However, when come to this line, plus A is first incremented. What is the value of A after the end of this line? It's 11 because this is a post increment. A is used, then incremented. Then again, because it's pre-increment, then 11 is incremented to 12 and assigned to D. So when you print this line, we're going to expecting that it will print 10 and 12. Okay. Look at this, the B value now, again, the decrement operator. So first, here, pre-decrement. That means B is decremented first, C becomes 9. Okay, then assigned to C. All right. Here, you see that first, the B is going to be used, then decremented. So what is the current value of B? 9. 9 will be assigned to D, then decremented, then B is updated to from 9 to 8. Right. So when you print here, we're going to get the value both as 9. Let's see the output. So here's my program. So you see that the C for increment operation, C value becomes 10 and 12, and for decrement, C is 9 and D is 9. This is how it works. Let's see another example of this category. So same thing, A and B are incremented to be 10, then we are incrementing B independently. It's not part of any expression. So B plus indicate that B will be incremented by 1. Okay. Then, okay, we have an expression here with the parenthesis. So A plus within the parenthesis with negative sign plus B within the parenthesis. So this entire result will be assigned to C and we're going to print the C. So how it works. First B plus B becomes 11 by the end of this line. All right. Let's come to this line. Parenthesis. Okay, we have 2 parentheses from left to right. Okay, so first this one, a plus plus. Okay, so look at this here. So a is going to be used here first. Okay, so a, what is the value of a? 10. So for this plus, this binary plus, the left hand side operand is going to be 10. Again, I want to eliminate the parenthesis, it is going to minus 1, minus 10. Okay, once 10 is assigned, then the a value is incremented to 11, a plus plus. So left hand side operand for this becomes 10. Okay, on the right hand side, plus plus b, whatever the value is b, now it is 11. First b is incremented, then used as an operand. So b becomes 12. So 12 is the operand on this side. So 12 on this side minus 10. So resulting value should be 2. So we will print the c. C is going to be 2. All right. Let's verify. Here is the program, and let's see the output. Okay. So as it is expected, you can see the output as C. This is how this increment and decrement operators work. So you are required to do more and more practice programs based on this, so you can get the see how they really works. Next comes to the next category. It's called relational operators. Mostly we'll see relational operators show the relation between the two expressions or two operands. All right, so we have this list of operands. Now less than, whether the left hand side operand is less than the right hand operator, then less than equal to, greater than equal to, double equal to. Here double equal to is actually equal to, right? Because when you use equal sign here, equal sign is for assignment, means assigning the r value of the, means the right hand side part of the equal sign to the left hand side. So to compare whether a left hand side value is equal to the right hand side or not, so we use the double equal to. All right, and for not equal to, just use the not operation, not symbol, and with the equal sign. All right, so always they will result in the condition of true or false, whether the expression is a logical output. Whether, if I say, I've given an example, a less than b, depend upon the value of a and b whether it's going to be true or false. Okay, means if I give a is equal to 10 and b is equal to 15, definitely 15 is less than 10 is less than 15, so this is true. All right, so the resulting expression will be a true value. When it is a true, it is going to be an integer value 1, and when it's false, it is going to be 0. So this true or false are mapped into the two integer values 1 and 0 always. All right, so you can see some examples like that. So not necessarily this both the side can be a single variable, can be an expression. Okay, that so because this operator has the lesser precedence compared to the arithmetic operators. So when we have arithmetic expression on both the side, either of the side or both the side, first the arithmetic operations are evaluated, then the values are compared using these relational operators. So for example, here a plus b less than equal to b plus c. First a plus b is evaluated, then b plus b c is evaluated, then it's compared. Okay, then the resulting true value or false value is going to be. So when you put this expression as a part of any other expression, depending upon its true value, the 0 or 1 will be assigned to that. Suppose I will write here that let's d equal to a plus b less than equal to b plus c. Then if it is really true, then the d will be equal to 1. If this is false, then d will be equal to 0. That's how these values are the results are assigned to any expression. All right. Some examples here. Let's say we are dealing with some characters, character and some integer values here. I equal to 1, 2, 3, and c is equal to b. So you say, so the expression I less than j, strictly less than j. All right. So 1 is less than j, definite. So it's true. So value will be 1. I plus j, 1 plus 3. Okay. Greater than equal to k. Yes, it is great. It is not greater than, but it is equal to 3. So this expression is again true. That's why it is 1. J plus k. J is 2. K is 3. Okay. So it's 5. Greater than, what is I? I is 1. Okay. And then 5. So 6. 5, it's saying that 5 greater than 6. Definitely it is not true. It is false. So resulting the value 0. K is not equal to 3. but k is already, the value is k is 3. So 3 should be equal to 3. All right. So when we write k not equal to 3, it is false. It's 0. All right. And c plus 4, c. So what is b value? B will be 0, 66. So 66 plus 4, 70. So 70 is equal to is 70. So this is true. This left hand side value is equal to 70. That's why this will end up with this. So this is how these expressions are evaluated. So here is an example for that with floating point values. All right. So you can see that I can figure out here the value of f is equal to 5.5, integer value I is equal to 7, and we have character w. So the ASCII value of w is let me see here. I honestly forgot at this moment. So ASCII value of w is going to be, I'll refer back so that we can evaluate it properly. I will be here somewhere. Okay, so let me refer to the ASCII table. I don't have to remember all the time. So the value of we're looking for small case of w. So it's 119. Okay, so I just remember this is 119. Right. So 119 is the ASCII value for small w, and let us evaluate using this value. So first, f greater than 5. Okay, 5.5 is definitely greater than 5. So r is going to be, because this results in true value which is equal to 1. So r will be equal to 1. When you print it, it will be 1 here. Then I plus f, I is 7, f, so we will get equal to 12.5. 12.5 is less than equal to 10. Definitely it is true. It is going to be, again, the value is going to be r is 1 here. C is equal to 119 because as I interpreted that the ASCII value of C, ASCII value of the W is 119. So this equals this relation operation double equal to is also going to be true. So R is 1 here. C not equal to P, definitely C is a W. That's why small w is not equal to P, P character P. So again it is 1. Look at the last one. C greater than equal to 10 into, what is C here? C is 119. So 10 into I plus F. What is I? I is 7. F is 12.5. So 12.5 into 12.5 into 10. So 125. So 119 is greater than equal to 125. This is false. Okay, because this value is 125 and this value is 119. So this is going to false. This is going to be 0. Also, when we evaluate this one, we'll see all ones, okay, except the last one. See, let's just relational. Let's see the outcome. So, second one is 0. I think I might have just interpreted something wrong here. What is the second value? Second value is I plus F. I plus F. All right. Oh, sorry, it's false. So it's 12.5. It's 12.5. Sorry, I thought of greater than. So it's 12.5 is definitely not less than equal to 10. Okay, it's not less than equal to 10. It is false. Okay, so this will be false. Very clear. I think interpreted I'm wrong. I've thought 10 on this side. So 12.5 is definitely less than 10, not less than equal to 10. Okay, 10 is less than equal to 12.5, less than equal to 10.5. So here it is. So this one is false. So this is true, this is false, this is all true, then the last one is false. All right. This is how the relational operator works. Then the logical operators. All right. So relational operators will show the relation between two parts. The logical operators will evaluate the logical output, logical result of the logical operation or logical output of the both expressions. So they generally used as a part of expression, okay, to see what is the logical out of the both expression. So they operate on the logical values. All right. So it doesn't matter whether you keep any expression on both the sides. The truth value, okay, we say truth value means not true. Truth value means either true or false. What is the truth value? That today is sunny. So if it is cloudy today, then today's truth value is false. All right. So if it is sunny today, then the today is sunny is true. All right. So that is the truth value of the sentence. Similarly here, so truth value of the logical operators, the expression will depend upon after evaluation whether it's true or false. All right. So and so they're evaluated with this logical operators. All right. So we have three logical operators here, and not logical and logical or. Right. So logical and means the AND operation, the that logic gets, if you know that the AND operation, if the output, or if there is a two input to the logical AND get, so if both the gate both the input is true, okay, if there is power in in both the input, then only the output will be one. If any of them has no input, okay, let's say zero, there is no voltage or there is no input to any of them, so output is going to be false. Okay, so it has to. But whereas logically, if any of them in logical OR, which is represented as two pipe symbol, if you see in your keyboard, there is a pipe symbol at the just above the enter. You have to use shift for shift key for that. So this OR operation, logical two pipe symbol OR operation, this will be true when one of the operand, okay, one of the inputs, if it is a logical OR gate, one of the input is true, okay, either left hand side or right hand side, it is going to be end up with the true. Okay, so same logic is applied for these logical operations. Although logical AND will be true if both the operands are true, its truth value of both the operands true, and OR operation, if one of them is true, fine, it is true. All right. So how you will evaluate? Suppose I got an I got an arithmetic expression. So how how going to evaluate the truth value of the expression? First, evaluate it, get a value in numeric value for that. Definitely, if it is an arithmetic operation, we'll end up with a numeric value. If you have a relational expression, definitely again we are going to end up with a relational truth value. Suppose I say C greater than D, just like here. So depend upon the value of C and D, either it will be true or false. If it is a arithmetic expression, it will be end up with some value. All right. So if any non-zero value, you enter with any non-zero value, maybe a negative, maybe positive, but non-zero value are interpreted as true value. If it is zero, then it is false. So depend upon on either side, whether it's a 0 or 1, okay, or true or false, the output of the logical AND or logical OR are evaluated, and not it will simply invert say the complement the truth value. Suppose it is the true, then it is going to be output is going to be false. If it is false, it's going to be true. Okay, it's a complement. So see this, let's evaluate the same thing with logical operations. All right. So this one is a less than symbol. We are not bothering about this first part. Let's come to this expression. Okay, I greater than equal to 6. I is 7. 7 is greater than equal to 6. So this is true. On this side, C is equal to W. This is also true. So because both the sides are resulting in a true values, this logical AND will end up with a true value. Okay, this will be evaluated to the true. So R is equal to 1 here. All right. Here, I is greater than equal to 6. I think this is true, but C is equal to 119. All right. Again, it is true because this is the ASCII value of W. So again, we end up with true. All right. Now look at the F. F is less than 11. F is 5.5, less than 11. It is true. And I is greater than 100. All right. Again, it is true. All right. Similarly, so we have these evaluations all. So now look at this point. 10 is less than 3. Definitely 10 is not less than 3. Okay. And 23. 23 is a non-zero value. So 23 is true. On this side, so look at on this side. All right. This side, we have 10 less than 3. 10 is definitely not less than 3. This is false. But this is false. This is true. Because it's OR, because one of the operand is true, this is going to evaluate. This is going to be evaluated as true. Right. So in this way, the entire expression is evaluated. And when you're using the sub-expression, make sure that you close all the parentheses properly. So look at this here. Because I have a sub-expression here, I put both the parentheses properly. If you miss any of the parentheses, you're going to end up with a compilation error. Okay. Let's run this program and see the output. Okay, so only the fourth one is 0, which is why I have not evaluated eventually. Couldn't I didn't that. Okay, this one will be false. Okay, this output 1 2 3 4, this one is going to be yeah, the fourth one is false. Yes, the fourth one is false, all other are true. All right, so this is how you use the logical operation. We'll see that this relational combination with the logical will be really helpful in our control structures or control statements. In the control statement, we generally what we do, we make a decision. If the evaluation this particular expression leads to a true value, we'll do some task. If this expression lead to a false value, we'll do some another task. Okay, so we have to make a decision. We cannot do all the tasks. We'll do some. The task has to be different depend upon the truth value of the expression. So in that case, these expressions will help us to evaluate the truth value. It will be put, it will be used as a part of the conditional statement of the control statements or control structures. All right, so we'll see this more on that. Next is assignment operator. As I told you, when you use single assignment, single equal to, just like in mathematics, it is only meant for assignment. All right, that means whatever appear on the left hand side will be right hand side, or R value, say R value and L value. R value expression will be evaluated, and the result of the R value will be assigned to the L value. So here we can say a simple 3 will be assigned to A, whatever the value of Y will be assigned to X, and delta will be equal to 0.001. Sum is equal to A plus B. First, that means on R value, first A plus B will be evaluated and will be assigned to the left hand value left hand side variable. Then length and width will be multiplied, or resulting value will be assigned to the area. All right, you will never ever have the case that left hand side will contain an arithmetic or any kind of expression. Always when there is an assignment, the R value will contain the expression, and L value will have definitely a variable, mostly a variable. So the right hand side value may contain a variable or may an expression that will be evaluated and will be assigned to the L value, the variable present on the left hand side. Next, to the bitwise operator. Bitwise operator, okay, are things which is applied on the bit level, as we have already studied in our previous session, the previous classes, that we represent everything, the integer value, everything we represent in the bit format when you stored in the memory. All right, so when we apply these bitwise operators, okay, the operation is performed at the bit level. Say for example, I have a character is generally stored in 8-bit. So if I apply this operation, the operation will be performed, okay, in an iterative way 8 times on each bit positions, from the leftmost the rightmost bit to the leftmost bit, or we say least significant bit to the most significant bit. Okay, that's why they are called bitwise operation. So, and the logic is same here. Bitwise not mean for complementing the bit. If the bit is 1, it will end up with 0. Okay, if the bit is 1, 0 will end with 1. Complementing, we will use not operation, complementing all the values, all the bit of a variable. So bitwise AND, same way, the way logical AND is applied, logical applied on the entire operand, the truth value of the operand. Now here it is applied on the truth value of the each bit on the bit level. Similarly, bitwise OR. Now there are two special things, also shift operators. What is shift operators? Shifting the bit. Okay, we have bits inside the bit in the memory. So for that variable, whatever result, the value, the bit of that values will be shifted, can be shifted either to the left, to the right, of depend upon how many times. Okay, so these operations, double less than or double greater than, represent the left shift and the right shift. So left shift, so what happens on the left hand side, we will mention the variable which is to be shifted, and right hand side the value that is to be how many times it is to be the shifting operation to be performed. All right, so this is how, so the operation is performed here. All right, so look at this example. A double less than 2 indicate that the left shift operation, the shift operation of bit, is performed 2 times here. So for example, I'll show this example here. All right, if my let's say I have a variable, let's say character variable, and whose bit values are, let's say 1000, 1100, for example. All right, and let's say I'm applying this left shift operation on these 2 times. Okay, when you perform left shift operation 2 times, this one in the end, first time when you first left for the left shift for the once, the topmost one will be lost. So this zero will come here, this 0 will come here. Okay, and this way the shifting will be done, and the least significant bit will be pushed with a 0. So this is the result of left shift operation. And if you look at the decimal equivalent of this on this and this, you will find that, okay, other than this first bit, okay, if you don't look at the first bit, because generally we didn't use for the sign bit. Okay, let's look at that. All right. Generally, when you do bit operation, if you ignoring the sign bit, you will see the left shift means multiplying the number with 2. All right. Now, if you do the right shift, okay, so for example, this is the value, and I will do right shift means if I perform a single right shift here, a 0 will be appended to the left hand side. So 0 0 0 0 1 1 0 0, it becomes like that. All right, so bits are shifted to the right. All right, so that means you would actually, we see that in this case it is divided by 2. All right, so this is how this left shift right shift operation will perform. Let's see this example, it will be more clear here. All right, so a is equal to 5, b is equal to 9. All right, we have taken this, we're printing the value of b, and you see that a and b, okay, a and b. So you know all the, because we're taking characters here, okay, one sign characters, so that we don't have any sign case here, we won't be sign bit. So 5 and 9, when you XOR this 5 and 9, you know that the 5 is let us take the value 5 in a character format. So 5 means 0 0 0 1 0 1. Okay, let this is 5, and 9 is 0 0 0 0 1 0 0 1. So when we perform what the AND operation, in the first we're going to operate perform the AND operation here, bitwise AND. So each bit in the respective positions are AND with each other. All right, so 0 and 0, so this all zeros will, because there, if there is 1 0, it will end up with a 0. So it means from left to, let us go from left to right, 0 0 0 0 0 1, again it's 0 1 0, it is again 0 0 0 0 1 1 1. So it should, so the resulting value will be 1. Okay, if you met an OR operation, bitwise OR here, so it's going to be 0 0 0 0, because there is a 1 here, it is 1 1 1 0, it will be 1 0 0, both are 0, that's why it is 0, and there are 2 ones here, definitely is 1. So it end up with this equal to 30. So its value is 30. End up with 30. All right, so this is how bitwise operation is performed. All right. So, and see that we are negating the value of a here. If we complement the value of a, okay, we'll find a negation value of a here, and we'll print it here. So when we complement, do just reverse the value of 1 a here. So we're going to end up with a larger number like this. Okay, so it will be, if you make it a negation of a bitwise complements here, 1 1 1 1 1 0 1 0. Okay, this is the point. This is how value is stored. All right, so let's see the output of this. All right, if we'll execute this program, okay, logical and or, and then here one more is that operator I actually forgot to mention, the exclusive or. Okay, so this caret symbol is meant for exclusive or. I think everybody know about the rule of exclusive or, which is there already in the in our slide also. So look at this side. So XOR operation means when there is a either one of them is 0 and one of them is 1, 0 and 1, then it will end up with 1. Means either of the input is 1, okay, then we'll end up with 1. If both are 1 or both are 0, then we'll end up with 0. Okay, the output will going to be 0. All right, so this is XOR operation. We'll actually if you have one value, it will make a 0. If you have already 1 with 1 or 0 with 0, it will end up with 0. So that is a property of XOR get. All right. So based on that, we get the output. So let me run the bitwise operation. Logical. Okay. I think I have to copy here. I haven't copied so far. Let's copy and run. Okay. As for bitwise, see, let me compile with S4 bitwise. Let's see. And let us run. All right. So you see that A and B is equal to 1. A or B is equal to 30. If you make a XOR, you will end up with 12. All right. Negation of A is 250. As I told you, it's a big number. Then we take the B. B is left shifted. So you can see the output will be multiplied with 2, 18. B is right shifted. Okay, by 1. B is divided by 2. So we'll take the floor. Always we'll take the floor. Okay. So is 9 by 4.5. So 4.5 floor value is 4. All right. So this is how the bitwise operations are evaluated. So you can work on again take some more example to learn and know more about bitwise operations. So here is an example of that how a XOR operation can be helpful. Everybody know how we can swap two variables. Okay, the value is given. Let's say variable has some value x, variable has 2 has some value y. I want to make sure that variable 1 will hold y and variable 2 will hold x. Okay, this is a simple way I can do that. I'll take two variables as input. I'm printing them before that, and then temp equal to var1. Okay, in a temporary variable, I'm storing the variable 1, and then variable 1 equal to variable 2. So it's like, I have 2 cup. 1 cup is containing coffee, 1 is containing tea. I want to swap it. All right. So I'll take another cup where first I will transfer the tea. Then in the tea cup, I will transfer the coffee. And when the coffee pot is empty, I'll transfer from the temporary cup tea to the coffee pot. So that's how it works. Okay. So this we'll see this again and again, because we'll see many ways to solve this one. All right. Then it is by using a temporary field. Then it is without using third variable, right? By using the mathematical property. So we add variable and variable 2 and store in var1. So var1 is now var1 plus var2. Okay. If it is var1 is 5, it is 9, it is 14. Okay. So 14. So from 14, if I subtract var2, okay, means I will subtract 9, I'll get 5. Okay, that 5 is nothing but my var1 value. Okay, now var1 value, whatever I get subtract, well, store in var2. Okay, similarly, then from var1, I subtract whatever the var1 is from var1 is there. Okay, with the sum, else whatever I got the var2, which is 5, subtract from var1, which will give me the second value, that is var2. I'll take that and store in the variable var1. All right, so it's very simple here. It's to swap the values using arithmetic operation without using third variable. Now the same thing we can also do with the XOR operation. Okay, so look at this: var1 equal to var1, XOR var2, var2 equal to var1, XOR var2, and var. So sir, how it works? Really, it's confusing. Let me tell you one property about XOR. Okay, so the XOR works something like this. You see that if I make one XOR, if I make one XOR 1, I'll get 0, right? Okay, and like, so you see that. Okay, here what this point is that, so if you suppose this is some variable a, some variable a. Okay, a bit 1. All right, 1 some, when 1 to 0 1. All right, again, suppose if I will XOR, mean to say that XOR 0 with 1, I'll get 1. So focus on this point. Okay, this is the first value. This is something value. Whether maybe a 0. If you replace this with a 1, if you XOR this one, this value, okay, twice. Okay, so with the same value, first we will get back the original bit. That's the idea. So when I XOR 1 with 1, I got 0. When I will XOR the result again with 1, okay, repeated, or I can say indirectly, if I'm just saying this, XOR 1, XOR 1, okay, I'll get the value back again 1. That is the idea here. Okay, I'll get the original one. All right, same with the 0 also. Okay, so if it is 1, if I'll XOR with 0, again I will XOR with 0. Okay, same value repeatedly, I'll get back the original value, whatever the results. Okay, so you make it a 0 or 1, so it doesn't work. So that's on that policy this particular program works. Okay, so see that what is you're doing. Variable 1 is equal to variable 1 XOR variable 2. Okay, again what you see that what I'm doing, variable 1 is equal to variable 1 XOR variable 2. If you replace the variable 1 here, what is the variable 1 here from the first line? Look at this line. So this line, so replace this variable 1 by this line, it will be variable 1 XOR variable 2 XOR variable 2. So remember, what is the rule of XOR? Any two same value will cancel, will get output will be 0, whether it's 0 0 or 1 1. Because of that we get back the original value, right? So XOR with same value will end up with always with 0, so that output will be the original one, the next value. So here what we're doing is that here in this program, the variable 1 XOR with variable 2 with variable 2. So variable 2 get cancelled, become 0. All right. So 0 with any non-zero value will get the same original one. All right. So that's why var1 XOR var2 XOR var2 will cancel var2, get me variable 1. All right. So in that case, what I'm doing, I will assign that variable 1 to the variable 2. Okay. Whatever value 2. Again, when I will use this variable 2, again with the part of that, I will XOR it. Okay, I'll get back the variable, I'll get back the, here I'll get the variable 1. So that variable 1 will be treated, it will be taken here, again XOR with this one, so that variable 1 get cancelled and I'll get the variable 2 here. All right, so meaning say that when you XOR one value with another value, same value, you get the output is 0. So using that property where we are swapping the values. All right, so this is how this swapping program works. Please, you can practice, even type it and see the output accordingly. All right. Next, especially the last but one operator is ternary operation. This is a special operation which takes 3 operands. All right. So it's a kind of control statement. It's not like a normal arithmetic or logical statement. Control statement. So what is it? It is represented like using a question mark and a colon. So before question mark, the first operand, it is generally an expression. Again, after question 1, second expression, and after colon, the third expression. So how it works actually? Either when it is part of any expression, first the expression 1 is evaluated. Depending upon the truth value of expression 1, either expression 2 is evaluated or 3. If it is true, expression 2 is evaluated. If it is false, expression 3 is evaluated. This is how it works, just like an if-else statement, which you will be learning in our control statements. Okay. So here's the example. Let's see this example and we'll figure out how it works. Okay. So m is equal to 15, n equal to 40. So m greater than n. That indicates m is 15, n is 40. So it is false. Okay. So since it is false, all right, this expression becomes false. Which will be evaluated? The n part. This part will be evaluated. So n. So n is evaluated. So this part is evaluated. So the result value is n here. Now, since I'm using this conditional operator as a part of a assignment operation, whatever the output is, that will be assigned to the L value. So n will be assigned to the L value here. Now, instead of putting any values here, we can also use printf statement. You can see that anything, any expression you put it, that is going to be evaluated. All right. Just don't put a semicolon here. All right. So then we print percentile d is the greatest number. So simply we are printing the greater number using the ternary operation here. If you give, let's say here 40 and 15, m will be greater than n. So true, then this will be evaluated. So m will be assigned to greater than. Depend upon this condition, either the left-hand side of the column or left-hand side operand of the column or right-hand side operand of the column is going to be assigned to greater, not both. Another one, enter a number. We take that number as a n. Expression is n modulus 2. Okay, n modulus 2 will result either in 1 or 0, right? Divide by 2, either it is going to be 1 or 0. So if it is 0, means false. Okay, if it is 1, means true. So if it is 1, that indicates that the number, what n, is an odd number. So we are print percentile d is odd. Otherwise, percentile d is even. All right. This is how it works. Let's run this one and see. And yes, we have to give a number. Let's say I give 45. 45 is odd, right? Same way, if I'll give again, I will give, let's say, 54. 54 is even. All right. So this is where the ternary expression is evaluated. Then the last one, which is size of operator, it looks like a function. Size of is an operator. Remember that. Generally, to compute the size of an operand. All right. So size of is an operator. It as I told you, it looks like generally we apply to a data type. Okay, we can apply, not only we can put an expression inside it, okay, or a value inside it, or a parameter inside it, to check the size, how much size it occupy in terms of bytes. Remember that size of will give you the output in terms of bytes, not in terms of bits. Right. So we can also, or we can also use size of to check the size of all the data types in the current compiler. All right, that we can also do. So look at this here. You're using this program to test the size of. So all these things will be in terms of unsigned long unsigned integer. So that's why we're putting LU here to print the value of size U. So size of character, size of integer, size of float, and size of double, it is going to print the what the current, how much byte they are holding in the current. Let me see whether I have a program ready for this. I think I have to test it accordingly. So let's copy and test. Yes, for size of dot c. Let's run this program. CC is for size of. And okay, so what are the things we're printing here? Size of character, integer, float, double. Okay. So character is 1, integer is 4 bytes, float is 4 bytes, and double is 8 bytes. As you can see, this is the use of size of. So not only this, I can put any number value also and constant also inside it, and I can say instead of character, what I will do here, let's say I'll put 5.2 here. Let's see. Sorry, not here. Sorry. I'll put in my program. Okay, here instead of that, I'll put 5.2. Let's see the output. Okay, so 5.2 by default, any floating point value will be promoted to a constant type, will double type. So that's what it is, 8 here. The output is 8. So any constant, any floating constant by default is of double type. So is a part of expression when you use a constant, the entire expression first convert into a double type and get developed, as I told you. Okay, so this is how we can test size of operator. And this is the entire hierarchy of precedence of all the operators that is there in C, right? So you can see that all unaries and parenthesis bracket, they are on the top one, and the assignments, we have other kind of operators, like plus equal to plus type. What I will tell you, show you now. Okay, this kind of operation can be part of kind of arithmetic statements common with that. So it's a special kind of thing. So for which I didn't get any sufficient examples, but I'll show you that. So we have separate kind of operators, which is also called the assignment, product by product, assignment by quotient, assigned by remainder, like that. All right. So these operators are combination operator, like plus with equal. Okay, if I'll write that A plus equal B, that indicate this is equivalent to A equal to A plus B. Okay, so it means like we have write A, then A, same thing, you have to put a star here, asterisk multiplication equal to B. Okay, that this is implies that it is A equal to A multiplication, A star B, A star B. Okay. All right, so this is how. So we have this plus equal to minus, and then I think minus equal to. We also have division equal to, also modulus equal to. Both all arithmetic operators can be combined with this assign operator to the please perform. Means we are not doing two things separately. First we are adding it, then assigning it. Okay, assigning can be done. So this indicate the second operand. This indicate the first operand and the L value. So A represent the L value and the first operand. B represent the second operand. That's how they work. Okay, so you can see the list of operators here. So you can see some examples from the book and any study material from that. So, and same thing also you can do with the bitwise operation. So these are all with arithmetic operation. Bitwise left shift equal to right shift equal to, all these things can be done at the same time. Also bitwise everything. Okay, bitwise with B and store in A. Previously, we were performing the operation and taking the help of assignment to third one. That both can be done together by using these expressions. All right, and we'll see the use of comma. Comma is the least precedence operator, and this is the hierarchy we should remember while evaluating any operation in C. Right. So that's all from my side. Thank you.